Hello, this is Professor Gina, and this video is going to cover some of the advanced techniques related to parabolas. I know that many of you have probably seen and graphed parabolas in your algebra classes in the past, but we're going to take a look at some of the more complicated um, ways that you can have the equations of parabolas, starting with this picture that I've got here from the textbook showing the different standard equation that you'll have if you have a parabola that is opening up-down with a vertical axis of symmetry or opening left-right with a horizontal axis of symmetry. We determine whether it's opening up if the letter P is positive, down if it's negative, and then similarly it opens to the right if P is positive, it opens to the left if P is negative. One of the things that you may not have seen in the past is this standard form, which is listed here, where we have it written so that the variable that's squared, in this case the x is squared, lets us know that it's opening up down, versus the equation down here, where y is the variable that's squared, that's where it's going to open left, right. And then those variables h, k that are being subtracted from x and from y, those end up being the vertex or the lowest point of the parabola. That value p is going to be the distance. It's here between the vertex and what's called the focus point, and then also here between the vertex and what's called the directrix, this line. Now, I posted on Canvas a website that shows you how a parabola is formed, and it comes from creating a set of points that are equidistant, the same distance from the focus to the parabola and then down to the directrix. So those two blue lines would be the same length. You can check that out on the internet to see examples of how that's created. So for our first example problem, we are going to look, we're going to find the vertex, the focus point. What just happened? And the directrix, which will be an equation of a line of x squared equals 16y. And then we're going to graph also. So this looks like the first equation where the x is the squared variable. I'm going to rewrite it in a little bit of a slightly different format so it looks more similar to that standard equation that's given. I will, even though it's overkill, but I'm going to write it as x minus 0, the quantity squared. And then I'll put the 16 out in front, and then this would be y minus 0. And then 16 is the same as 4 times 4. I'm just doing this to show you the general structure, where if I have it in this format, this would be the variable h. This would be the variable k. Again, h, k are the coordinates of the vertex. And then this number here is going to be p. That tells us the distance between the vertex and the focus, vertex and directrix. So I know by looking at this equation the way that I have it that the vertex is the point 0, 0. The focus point is going to be 4 units or 4 steps up from 0, 0. I'll make my graph green. So here's my vertex. Because p is equal to 4, the focus point is going to be here. I know that the graph is opening up because p is a positive value, right? And so the graph is going to look something like this. So I think that the focus point based on the graph that I have there is the point 0, 4. Now the directrix is going to go down from the vertex. It's going to be going in the opposite direction. So it'll be down here. It's not part of the graph, it's just this line that's used to form the graph. And so the directrix is going to be the line y equals -4. So these are the key points that we wanted, and then we were also able to get a picture of a graph. Okay, let's tackle another example like that. Let's find the vertex, focus, and directrix. Oops. Of y squared plus 4x equals 0. And then we'll also graph, right? This one is not quite in the format that we want, but because y is the squared variable, we know it's going to be in the opposite format, the one that's going to be opening up left, right. So I'll start by rewriting it. I'm going to rewrite it into the form y squared equals -4x. I'm moving the x and the y variables onto opposite sides of the equal sign. And then similar to what I did in the last problem, I'll rewrite it so I can extract what the vertex and various other things are. So I'm going to write this as y minus 0 squared. This is 4 times -1. Remember, the format is always 4 times a number. And then for the x, we have x minus 0. Now, x and y are in different locations now. So this here is k, and this here is h. Doesn't matter so much in this context because the vertex is going to be the point 0, 0 again. P is -1, so that tells me that the graph is going to be opening to the left. So we're going to have the vertex at 0, 0. The graph is opening to the left like this. So that means that the focus point is going to be here, which is going to be 1 over to the left. So the focus point is -1, 0. And then the directrix is going to go the opposite direction. It's going to go to the right of the vertex. So the directrix is going to be the line x equals 1. And so this is all the key information that we were asked to find. All right, let's look at one that's a little bit more complicated than that. Let's find the equation of a parabola with focus at -√2, 0 and directrix at x equals √2. I'm going to draw a picture to start with this. Let's draw a picture of this. So we know that at -√2, 0, we have a focus point, and then the directrix is at x equals √2 over here, and the vertex has to be in the middle of those. So since those are both the same distance from the origin, I think the vertex in this context is going to be at 0, 0. And then we need to figure out what the distance p is. Well, p is going to be the square root of 2, right? So this is going to be a parabola that's opening to the left. So the general format for that kind of a parabola is y minus h squared equals 4p x minus, oops, that should be a k, right? We know that h and k are 0, 0. So we have y squared equals 4. We know that p is the square root of 2. And then x is also, or sorry, h is also 0. So I have y squared equals 4 times the square root of 2 times x. That's the equation of this particular parabola. Find the equation of a parabola with focus point -2, 3 and directrix at y equals -3. All right, let's draw a picture to see what this looks like. So my vertex is over here, -2, 3, and the directrix is at negative y equals -3, so down here. So the vertex is going to be in the middle of those. It looks like the vertex is going to be there. I think that the vertex for this is going to be -2, 0. And this looks like it's going to be opening up. So the general format of this will be x minus h squared equals 4p y minus k. P in this case is going to be this distance, right? Or this distance is p. So I think p is going to be equal to 3. So putting this all together, we have x minus a -2 squared equals 4 times 3 is p, and then y minus 0. So this is x plus 2, the quantity squared, equals 12y. So that's the equation of our parabola in this case. All right. Let's tackle a couple of examples that are a little bit more complicated. These are more like the examples that you'll see in a calculus class. Let's find the vertex, focus, and directrix for x squared minus 4x minus 2y equals 0. And then we'll draw a graph too. The first thing that I want to do is separate the x and the y variables, and I will try to keep the squared term positive. So I'll keep that x squared on the left. I'll rewrite this as x squared minus 4x, and then I'll move the 2y onto the other side. I left a little space on the left, and you'll see why in just a moment. I know that I want the left-hand side to be of the format of x minus h squared. And so I'm going to go through a process of completing the square. And we talked about this probably 2 months ago now. Just to remind you, what we do is we look at the middle term. We know that the middle term is the one that has the variable raised to the first power. We take half of that value. So half of -4 is -2. And if we square that number, we put it up here, -2 squared is going to give us a +4. And I'm going to add 4 on the other side. I need to balance out the equation. I can't just add numbers in because it changes the original equation. Adding 4 would shift the whole graph up, right? But if I add 4 to both sides, it's not going to change the overall original that I had. All right, so now the left-hand side can be written instead as x minus 2, the quantity squared, right? X minus 2 times x minus 2. And on the right, I can factor that 2 out. I'd have 2 times y plus 2. So then rewriting it to be more like the format that the standard format, the left side can stay as it is, x minus 2. But I'm going to write 2 instead. I want it to be 2 is going to, I want it to be 4 times some number. That's the same as 4 times a half. So I'll write this as 4 times a half. That way I can see that p is equal to 1/2. And then I'll write this as y minus a -2, right? Because now I can say that h is equal to 2, k is equal to -2, and p is equal to 1/2. That helps me find the vertex and the focus and the directrix. So the vertex is the point 2, -2. The focus is going to be, this graph is opening up, right? This parabola opens up. I know this because x, it's x squared, which is always up, down, and p is a positive number, so that means we're opening up. The focus point is going to be 1/2 up from the vertex. So to go up, it's in the direction of y. So the x term will stay the same, but I'm going to take that -2 and add 1/2 to move up. Let's draw a graph just to show you what I'm talking about. Our vertex is at 2, -2, so here. The focus is going to be a 1/2 step up, and then the directrix is going to be a 1/2 step down, right? And the graph is going to open up this way. So our focus point is 2, and then -3/2. And then the directrix is going from -2 and then subtracting a 1/2. So that's the same as y equals -5/2. So here's our vertex, focus, and directrix. All right, one last example of a parabola that's similar to what we just did, but opening left, right. Let's find the vertex, focus, and directrix of y squared plus 6y minus x plus 16 equals 0. This chapter that we're in right now talks about all the different conic sections, and many of the formulas that we are encountering, many of the equations we're encountering look similar to this. One of the ways that we know that an equation is a parabola is when only one of the variables is squared, as is the case here. Because y is squared, we know that this graph is going to open left, right? So I'll start by rewriting it, putting everything with y onto the left-hand side, and then all of the other terms on the other side. And I'll leave a little bit of space because I know that I'm going to complete the square. So I take half of 6, which is 3, and then I square that. 3 squared is 9, so I'll add 9 to both sides to keep the equation balanced. Let's simplify what we have. The left side simplifies into y plus 3, the quantity squared. And on the right, we have x minus 7. Now, I don't have a number in front of x, so what I'll do to put it into that format of 4 times p, I'm going to put 4 times 1/4. That's the same as just 1, right? And then I've got x minus 7 here, just to kind of figure out what p is in this case, right? This is p. This is going to be h. And then on the left, we'll write it as y minus -3 squared. Remember, it's always subtracting a number. So then I know that k is equal to -3. Okay, so let's look at a rough sketch here. We know that our vertex is going to be at -7, -3, no, +7, +7, -3. And then the focus, let's see. So down here, the focus is going to be up. No, this is opening to the right because p is positive. This is going to open this way, right? So the focus point is going to be here. The focus point is going to be 7 plus 1/4. We're moving to the right by 1/4. The y coordinate will be the same. So 7 1/4, that's 28, 29. 29 over 4, comma, -3. And then the directrix is going to go the opposite direction, 1/4, right over here. So, and again, that goes from the vertex. So the directrix is going to be x equals 7 minus 1/4, which is x equals, that's 6 3/4, which is the same as 27 over 4. So here's our vertex. This is the focus point. And this is the directrix. Okay, thank you for watching. Look for a couple other videos on circles, ellipses, and hyperbolas. Have a great day.